Why you shouldn't optimize your code immediately, but why you should still do it. I'm going to say this now. Don't optimize your code immediately. By not optimized code, I don't mean not clean code, but rather code that isn't necessarily fast as it could be. One of the main reasons why you shouldn't optimize your code immediately is that you get your ideas out slower. Whenever I have a good idea or what, I try and get it down as fast as possible, cause we forget. Yes, it's that dead simple. We forget. Optimized code is going to make your ideas come out slower, and quicker your ideas come out, the more quickly you'll see if this idea is worth it or it's going to get scrapped. But if you spend 3 hours on making really optimized code instead of the 1 hour you could have made using less optimized code, and the idea isn't good, well, congrats, you just wasted 2 hours. Optimization doesn't make a game more fun to play. To prove my point, I'm going to give you 2 games to play. Mario with only 1 level that's really fast and optimized, or Mario with 100 levels but is really slow. I think if it was me, I would choose the one I could play longer and have more interesting variation than one that was really fast. I would just imagine the Mario with 100 levels but is really slow as a Mario where time is incredibly slow. Why optimize your code though? I'm going to mention one example, Factorio. In Factorio, there can be many thousands of belts, and each carry many individual bits of material all around your factory. Do you think the game would have been possible if they hadn't optimized it? No. But how do you optimize? For example, say you made an entire system of trees. Each tree will contain a variable for a mesh of a trunk, variable for a mesh of a leaf, and variable for a position. But if you have 1,000 trees, you'd have 10,000 different trunk variables and rip the memory bus to your GPU. However, when you optimized it, you create a class perhaps called Universal Tree Class. In Universal Tree Class, you'd store the mesh of the trunk, the mesh of the leaf in the class, and all those trees are probably the same. Each tree in your forest is probably going to be the same. Then you send it to the GPU using instant rendering, which is sending one piece of data but creating many instances with it. And then you can have each individual tree's data, aka the position, will be different. And there you have it. You reduce the amount of data you need to send and your game will be much faster. This is obviously just one type of optimization, but you get the gist of it. You don't make new features, you make existing ones faster. And that's it for this video. I hope you enjoyed this video on optimization. If you liked it, please smash the subscribe button.